I did the initial commit for Hopin's Next.js project, which scaled to over 100,000 monthly active users. And my company, React Squad, works with dozens of Next.js projects, some of which have over 1 million monthly visitors. And in this video, I'm going to share with you all the hard-earned lessons that I needed to learn through countless iterations so that you get your app right from the start. Because it doesn't matter if you're working on a small code base with just 1, 2, or 3 developers, or you're working on a large one where multiple teams collaborate together on the same code base. This video is going to share with you some important nuggets that you need to learn so that you can avoid having to set up everything later, because later it's always harder. It's possible, but it's super hard. So let me take you by the hand and walk you through all the packages and steps that you need to set up to get your setup correctly, because I'm also going to tell you why they're useful to you. And you want to start with creating a blank Next.js project. It may ask you whether it can install the latest version of the Create Next app package. Just hit yes, and then also hit yes to all the other prompts the CLI gives you, such as Tailwind, TypeScript, and the app directory. Then change into the directory of your app and open it in your favorite editor. Then you want to run npm run dev to verify that your project works and check it out in your browser of choice by visiting localhost 3000. And afterwards, you want to add a type check script to your package JSON. You're going to use this command later together with other static analysis checks. When you work together on a large team, then you want to agree on how everyone writes code. So get together with your team and make important decisions, such as do you want to use white space or tabs, do you want to use semicolons, and do you want to use single quotes or double quotes. And then once you've made those decisions, you want to use tools that enforce the way that you write code for everyone, so there are no discussions during code review around the code style. And one of those tools is Prettier. Prettier is an opinionated code formatter, and you can install it together with the Tailwind plugin. Then create a Prettier config with your favorite rule. I personally like a tab width of 2 and having semicolons. Then add a command to format your code to your package JSON and run it once. Now all of your code has been made prettier, but you also want to use ESLint. ESLint is a tool that scans your code for both logical and stylistic issues. Install ESLint with its plugins Playwright, Unicorn, and Import Sort. Then modify your ESLint rc.json. These plugins all have different functionalities, and if you want to learn more about them, visit their respective GitHub pages. But in short, what they do is they make sure that your code is written well, especially when you write modern JavaScript features, and they make sure that your imports are sorted. Since Prettier and ESLint can sometimes interfere with each other, they make sure that they work well together. And lastly, they make sure that your Playwright and Vitest tests are written in a good style. Add a lint script to your package JSON and run it to format your code according to your new rules. Note that this tutorial uses ESLint 8, even though ESLint 9 already came out. And the reason for that is that many of the plugins are not compatible with ESLint 9. And when you work with a large team, another thing that you want to streamline is your commit history. The reason for that is that a streamlined commit history allows you to auto-generate changelogs and auto-increment your semantic versioning when you release new versions of your app. So install Commitlint and Husky. Next, initialize Husky. This step also sets up the basic configuration. And then customize your hooks so that your code is automatically linted and type checked on each commit, and also customize your commit message. Then remove the line that says npm test from your pre-commit hook and make sure that your scripts are executable. Here chmod stands for change mode, which is a command on Unix and Unix-like operating systems to modify the permissions for files and directories. And x+a says that all users should have execute permissions to those files. And now install Commitism, which is a CLI that allows you to craft conventional commit messages. Configure Commitism in your package JSON to use the conventional changelog standard. The conventional commit standard is a specification that makes your commit messages both readable to humans as well as machines. And this allows you to automate your changelog and your semantic versioning based on your Git history. A future video will outline the specification in detail, but it's already included in this tutorial so that you can get it right from the get-go and already reap its benefits. Create your Commitlint config.js file with rules that suit your team's needs, and then run the commitism command to start crafting your first commit message guided by a CLI. The CZ command will ask you a series of questions and then write your commit message for you. Now that you're done with your static analysis tools, it's time to look at your folder structure. You can either group files by type, which is when all your reducers live together, all your components live together, all your tests live together, right, all in the same folder, all the files related to the specific type are in the same folder. Or you group files by feature, which is, for example, when all the files related to your authentication are in one folder, and that includes your reducers, your components, and your tests. This approach has several advantages. The first advantage is scalability. Large applications are easier to scale and maintain because each feature acts like a mini application. You avoid scrolling up and down as you filter for the right file that you want to find. The next point is better collaboration. So developers can focus on specific features without disrupting each other's work. You also get faster onboarding because new developers in the project understand the project structure faster. Refactoring is also easier because all the files that you need to update live together. The modularity of your code that you get when you group by feature allows your features to be reused, shared and turned into standalone packages, which also prepares your whole application to eventually become micro frontends if you ever need it for scaling reasons. Take a look at this example that shows you exactly how your code could look like when you group by feature. As you can see, test files live next to the respective implementation files. But anything that is shared by multiple features is then grouped in general folders such as components or hogs or hooks. Shared setup for state management in this example for Redux lives in the Redux folder. Some people like to group by feature within the app directory. Here's how that can look. This tutorial is going to use the first way to group by feature, but you pick whatever you like most. Now it's time to think about your testing setup. It is recommended for you to use Vitest because Jest is the most popular framework, but Vitest has the exact same API, but the tests run a lot faster. Install Vitest and add a test command to your package.json. Then create a simple example test that just checks that 1 is 1 and run it. It should pass. By the way, if you want to learn how to write better tests, check out this video that teaches you 12 evergreen testing principles that every senior engineer should know. You also want to write tests for your React components, so install React testing library. Then create a vitest config.ts file. It sets up the test environment and specifies parameters such as that your tests are running in HappyDOM and how your test coverage reports should be formatted. Now create a file to set up your test environment. The first line imports additional assertions that allow you to test for DOM nodes, such as are they visible, what text content do they have, and whether they have certain attributes. The second line makes sure that React works well in concurrent mode when you do state updates. Next, create a file to set up a custom render method. You can use this custom render method in your tests to wrap your components in providers, such as for Redux or layouts or styling. Then make sure your configuration worked by writing a test for a React component. You import render and screen from your test-utils file directly instead of importing it from React testing library. And the to be in the document assertion is one of those special assertions that you set up in your test environment configuration file. Now, when you run this test, it should pass too. Let's talk about the styling of your project. When you style your project, there are two things that are important. First, maintainability, and secondly, accessibility. Accessibility is when people who rely on screen readers still can use your app perfectly. And a good library for this is Shadcn. It just came out recently and it's hugely popular. It uses Radix UI to give you accessibility and it uses Tailwind to make your styles maintainable. So initialize Shadcn in your project. The setup for Shadcn is already done, and now if you need any component for your project, such as for example a card component, you can simply add it to your project by using the Shadcn CLI. As your app scales, you want to ship it to more users, and to do that you need to translate it into multiple languages. That is called Internationalization or I18N, and adding that to an app at a later stage can be a huge pain because you will have to find all of your hard-coded strings and then replace them with translation functions. So let's get that right from the start. So install the negotiator package and a local matcher. The negotiator package detects your user's browser's preferences, and then the local matcher takes those preferences and matches it to the corresponding translation that your app is offering. Also install the TypeScript types for the negotiator package. Create an I18N config, and it is only going to contain the settings for the English language for this tutorial, but you will see it will be trivial for you to add other languages later. Then use your I18N config in your localization middleware. In your localization middleware, create a helper function called getLocal, and that takes in a request and then uses the local matcher to match the correct local for the local that your user prefers, which the negotiator package detects. And now you can use that getLocal function in your actual middleware, which redirects the user to the correct path. The purpose of this middleware is to automatically detect and redirect your user to the appropriate version of your website based on their browser language preferences. Now create a middleware.ts file in the root of your project and import and use your localization middleware in that general middleware. This middleware is configured to ignore any static files and all of the API routes. Now it's time to add your translations. Create a JSON dictionary for the English language and add all of the strings for the English language that you're going to use later. And then create a new file that is for your getDictionary function. The getDictionary function lazily imports all of the dictionaries and then takes in a local and then picks the dictionary for the corresponding local and returns it. Now, if you want to have the ability for your users to switch the language manually, you need to create a component for that. Here's how that component can look like. You can create a custom useLocalSwitcher hook that uses the usePathName hook from Next.js to get the current path name. And then you can create a custom function that takes in the desired local and gives back the URL, the href value, of that desired path name with the new local. And then you can simply use your hook in any component and pass it to a link tag so that the link tag redirects the user to the new language. Since Next.js has file-based routing, you need to change the structure of your code a little bit to support internationalization. So create a lang folder in your root app and then move your pages and your root layout into that folder. Then modify your root layout to set the current language on the HTML tag. Now, in any server component, you can grab the current language from the params and then use the getDictionary function to do the translations on the server. Now, you can only use the getDictionary function in your server components because those translations are lying on your server, right? They are not shipped to the browser. So in order to do that, in your client components, they need to take in the dictionary and then they can access the translations from that dictionary. So if you want to render a client component in your server component, pass the dictionary to the client components as props. Now your app is ready to be shipped all across the world because it is available in any language that you choose. But what would an app be if you couldn't persist data? You need a database. This tutorial is going to use Postgres because it's very well beta tested and has been used all over the world, so it's always a safe choice as a database. But you're also going to use the Prisma ORM, which abstracts away your database layer, so you can just switch it out for a different database if Postgres doesn't fit your needs. So install Prisma and then install the Prisma client. Then initialize Prisma. This will auto-generate your schema for you. Now add a user profile to your schema, which consists of a name, an email and a boolean, whether they accepted your terms and conditions or not. Then you will have a .env file if you ran the npx prisma init file, which you need to rename into .env.locals. Then make sure that you have your database credentials in your environment file. Now create a prisma.ts file, which will contain your database connection to your Postgres database. You declare the Prisma variable globally so that TypeScript knows it's available everywhere. So you're going to check whether your node environment runs in production or not. And then you're going to either create a new Prisma client or reassign it to the global variable. The reassignment ensures that in a non-production environment, like during development or testing, only one instance of the Prisma client is created and reused across the entire application. This approach prevents the need to repeatedly initialize the database connection every time a module that needs access to your database is imported. Modify your package.json to include the following Prisma helper scripts. Some of these commands make use of the runs, .env and tsx packages, which you will need to install. Here's a breakdown of what each Prisma command does. Prisma deploy deploys database migrations and generates Prisma client. It runs migrations on production databases and updates the client API. Prisma migrate creates a new migration from changes in the Prisma schema, applying it in the development environment. You must specify a name for the migration after the command. Prisma push pushes the schema changes directly to the database and updates the Prisma client. This is useful for prototyping without creating migration files. Prisma reset dev resets the development database by wiping it, reseeding it, and applying migrations in the development mode. Prisma seed runs the TypeScript seed script to populate the database with initial data. Prisma setup generates the Prisma client, deploys migrations to the database, and pushes the schema to the database. Prisma Studio opens Prisma Studio, which is a graphical user interface for viewing and editing the database records. Finally, Prisma wipe resets the database by forcefully dropping all data and migrations, and then pushes the schema changes. Now run the Prisma setup command, and if Prisma doesn't recognize your environment variables, you can set it manually in your terminal by using the export command on Mac. Create a seed file. You can use your seed file to populate your database with initial values for your development environment. Import the exit command from Node and import the Prisma client. Then configure your .env so that all environment variables are loaded. After creating a Prettier print helper function, you can now write your seed function, which sets up a user profile. Then run your seed function, and after it has finished running, disconnect from your database. As you add more models to your database schema, you probably also want to create entities in your seed file for that. If you now run your seed script, it will create your first user for you. Now you can use Prisma in your server components to fetch data from your database. And you can only use Prisma in your server components because on the client, you don't have access to your database, right? Because only your server components run on your server. So import Prisma and import the card component from Shadcn that you installed earlier. Then fetch the user profile that you seeded and render it in that card component. It's a good idea to abstract away your database calls using facades. A facade is a design pattern that provides a simplified API to a complex subsystem. So create a file that contains all the facades, all the database calls to your user profile model. Now in your model helpers file, you only need one facade, which takes in an email and then returns the user for that email. In general, facades have two big advantages. First of all, they give you resistance to vendor lock-in, which means that if you're using, for example, Supabase and you're using facades, you can easily switch to Firebase because you don't need to change all the API calls everywhere in your code base. Instead, you only need to update your facade. The second big advantage is that facades simplify your code. You can reduce the API down to only the necessary arguments to do the database operation that you want to do. And you can give your facade a very descriptive name so that people who read your code can understand easily what the database call does. Now use your facade in your React component. Swap out your hard-coded database call for your facade. Since you're using Next.js, you probably want to deploy on Vercel. And there's Vercel Postgres. They have an easy-to-follow documentation, but here are the steps to set up Vercel Postgres in your project for your convenience. Go to the Storage tab and click the Create Database button. When the Browse Storage modal opens, choose Postgres and click Continue. For creating a new database, when the dialog box opens, type your preferred database name in the store name field. Ensure that the name has only alphanumeric characters, underscore, or dash, and doesn't exceed 32 characters. Choose a region. For lower latency, select a region close to your function region, which is US East by default. Finally, click Create. Then you will need to add Postgres URL non-pooling to the data source in your Prisma schema. Vercel uses connection poolers, which manage a pool of database connections that can be reused by different parts of an application. Rather than establishing a new connection for each database request, direct URL property is used to ensure operations requiring direct database access, such as migrations, can bypass the connection pooler for reliable execution. You can get the environment variables for your Postgres database by pulling them directly from Vercel using the Vercel CLI. Now let's talk about end-to-end tests. End-to-end tests are the most important type of tests because they give you the most confidence that your app is working correctly. Far too many people skip out on them, so make it a habit to write end-to-end tests. The benefits are compounding. This tutorial is going to use Playwright, so initialize Playwright. Initialize the script exactly how you see it on screen. If this is your first time using Playwright, check out the examples folder that gets created by the initialization script and then delete it because you won't need it anymore. Modify the web server key in your Playwright config to run your app in production mode in CI and in development mode locally. Now add two scripts to your package.json. The first one runs Playwright in headless mode and the second one runs Playwright in UI mode, which gives you access to things like time travel debugging. Then create your first Playwright test. Import expect and test from Playwright, then write a describe function for your landing page and make sure that the user that is being created in your seed script is rendered correctly. Now run your Playwright test to make sure that your setup worked correctly. All three tests should pass. Why 3 tests? Well, because by default, Playwright runs in 3 different browsers: Chrome, Safari, and Firefox. Now, you want to tie together all of the setup so that it runs automatically when your app deploys. For that, follow me to the next location. Let's talk about the secret sauce to tie it all together, which is called CI/CD, which stands for continuous integration and continuous deployment. Continuous integration into what? Right? Into your code, into your repository, which means that you're going to have checks like your linting, your unit tests, and your end-to-end tests that run whenever someone wants to merge code into your code base and that run whenever you want to deploy code to production. Depending on your platform, the way that you do this is different, but this tutorial is going to use GitHub. So configure your database URL secret in your repository secrets. Create your Github Actions YAML file, which will contain all the code for your linting, your testing, and to run your end-to-end tests automatically. First, make sure that it runs on every pull request. Then set up the different jobs. You want to set up linting, which makes sure that everyone adheres to the same code styles, and type checks, which makes sure that there are no TypeScript errors. Then you want to set up Commitlint, which makes sure that everyone writes the commit messages in the same way as we described earlier in the video. You also want to set up checks for Vitest, which runs your unit and integration tests. Then you want to set up checks for Playwright, which will run your end-to-end tests in different browsers. They're configured to capture artifacts when your tests fail, which are just recordings of your user interface, which you can download to debug what went wrong in your CI/CD pipeline. This is something that you might need to do occasionally because sometimes, even though it works on your machine, right, the tests can fail in CI/CD, and this is an excellent tool to help you debug your CI/CD pipeline. Thank you so much for watching. Subscribe if you learned something, and the algorithm thinks that you will learn valuable lessons from watching this video next.